Now that we have this expression to talk about probability of some hypothesis or idea being true given evidence, there is the question, of course, of how we try assigning these numbers. In particular, if it's about assigning probabilities to beliefs rather than things you can just go out and simply count and look at ratios directly. So here we should be discussing first the term that describes the prior probability, or PA here. A is your hypothesis, your idea, the thing you're testing against evidence B. And the question is, well, what is it to even have a prior probability? How do you assign some value to it? The prior probability ultimately should somehow depend on background information that you somehow have. It should be about the previous beliefs or information you have that suggest how likely that hypothesis is going to be true. How well does it, for example, conform with other things that you know? How well does it conform with how often things are right, given that sort of information? Now, there are sort of direct objective ways of figuring out what that might be. So, for example, in the case of medicine, we might look at a population. So, for example, I could think of what's the background rate that people have some certain disease. So that background rate, I could just go out and measure and find that 3 out of 10 people end up having this disease that gives them blue skin. And supposing otherwise, they would have red skin with my wonderful color scheme here of these stick figures. So this would just be direct going out and measure and finding out how often it's the case that somebody has such and such a disease. So in some times it's just simply knowing what is, in that case, the background rate. So in this case, the probability that any given person that you nab that has the disease that makes them blue would simply be the number of people that have that disease, number of blues, divided by number of people out there. So in this case, 3 out of 10, or 30% if you prefer in probability or not percentages. So in that case, it's nice and straightforward and simple. Other cases, maybe it's not so easy to directly measure. For example, if I ask you, well, what is the prior probability that string theory is the best theory to explain quantum gravity? Not only is it the case that you're going to have to learn a lot of physics to understand what is string theory, what is quantum gravity, what is it trying to do, but it's also not going to be the case that you can just go out and grab a bunch of theories and see which one are true just by a counting procedure. What's going to matter ultimately is other background information you have and see if it's consistent or not consistent with that. Let's take a look at, for example, an historical hypothesis, something that we're trying to guess about the past. So we're probably all very familiar with the magnificent pyramids of Egypt, especially those on the Giza Plateau. There is in particular the very Great Pyramid of Khufu, usually dated to around somewhere in the range of like 2500 BC. And if you are an Egyptologist, there are various theories out there about how it was built. Some suggest that the blocks that were put into place, and by the way, there are a lot of blocks. And none of them, of course, are easy to lift. If you go and find out how big they are, you'll see that, each one of them is around like a couple of tons. So not something that a person will just pick up and put into place. So there's been a lot of different hypotheses of how the stones were put into place. One idea was that perhaps there would be some sort of ramp that stones could be moved up. Problem with that, of course, has the case that as the pyramid goes larger and larger, as you keep needing to make a ramp that's taller and taller, you end up creating a ramp that is basically of greater volume of material than the pyramid itself. These ramps end up getting like over a mile long, and that becomes pretty much you need to almost to build a pyramid in order to build a pyramid. So that makes it a difficult theory to fit, just given the tremendousness of the task. There's another idea that, perhaps maybe instead of a long ramp, maybe you could have a ramp that basically twists around the pyramid. And so this be some sort of a side structure that is built up along with the pyramid. It doesn't become tremendously long, and you would still have all the advantages of a ramp that you can move the blocks into place without having to directly lift them up. This actually introduces some engineering problems of itself, in particular if you want to make sure you're putting all the blocks into place, getting everything level, etc. So there are engineering issues if you try to apply something like this, but at least it doesn't have the monumental task of building a pyramid's worth of dirt. Perhaps instead there would be some system of pulleys and levers lifting things into place. And there's actually several different forms of this hypothesis, some of them in particular using a system of counterweights. So that way you have the advantage of using a pulley or a lever that gives you some mechanical advantage, but also using the weight of other rocks to help lift that into place. In the same way with an elevator, there's a counterweight, so the motor doesn't have to directly lift an entire car up, just the weight difference between the counterweight and what's in the elevator. This one will depend on what technology sort of existed at the time, which we can glean in part from the writing or the pictures left by the Egyptians. So maybe there's a possibility here, but it requires a lot of additional information and seeing how well it fits to the construction methods. If you go outside of Egyptology, you might also find some other hypotheses out there. Perhaps one that's been on television a few times somewhat recently is perhaps some sort of craft from another world able to use some sort of tractor beam technology and just lift the blocks into place. Well, I would get past the technological hurdles if we use an advanced enough civilization. Okay, so like I say, there's lots of different hypotheses we could come up with, but they can't all be right. They can't all be probably the right answer even. In actual fact, one of the issues we're going to have is that the probability for each one of these hypotheses, if we want to add up each prior, all of them have to add up to 100% or 1. So, for example, the probability of the ramp, the probability of the twisted ramp, the probability of ancient levers, the probability of alien intervention, all of those probabilities would have to add up to 1. So if we were to just completely delete all of our background information and say these are the 4 different hypotheses, then we might say each probability is equal. So we have 4 different possibilities, all of them equal. So any one of them out of the 4 possible would mean that each one would have a probability of 1 in 4, or 25%. But it seems rather absurd, given our background knowledge, to think that, for example, the ancient tech hypothesis is just as probable as the ancient astronaut hypothesis. For one thing, again, we have Egyptian writings. They show them moving things around with things like ramps, with ropes, with sleds. What we don't see them drawing are flying saucers using tractor beams, putting things in place. That seems already a bit off. If that's the case, that the Egyptians are ultimately constructing their pyramids through that sort of intervention, or at least assistance, at the very least you might expect that. Or you might also think, well, what are the chances that there even is intelligent life out in the universe? One of the things we don't even know is if these guys even exist. We don't yet know for sure if life exists elsewhere in the universe outside of our solar system. It might be probable, but we don't yet know it. We definitely don't know if any of that life ever became intelligent and technological, and we definitely don't know if they've ever produced a spacefaring system, let alone do we have any knowledge that they've really actually come over the many, many light years to travel here. And in fact, we can even do some of the physics calculations and realize that the energy investments involved are so gargantuan that it's not that probable overall to even expect such a thing, even if there are such creatures. And of course, why they would come here and instead of building with advanced metals or polymers and plastics, they put a bunch of stones together. Really, a pile of rocks is what you'd expect from a civilization that can travel the light years? Like I said, these are all things that you would make us think that the prior probability of the ET hypothesis is going to be pretty small. I mean, like, really small, given that sort of background information. Now, of course, how small is not easy to determine. What I am saying, though, is that it should be less than the probability of any other of the hypotheses we've mentioned here, just given our background knowledge. So it should definitely be less than a quarter. And really, given the fact that what we know of, what we have limits on when it comes to things like physics, the requirements that it would take for someone to even get here, and the background knowledge of what we have about the ancient Egyptians and what they wrote about and what they didn't write about, I would, if anything, think the probability would be less than 1 in 1,000, personally. Now, how I could ultimately assign a number might be very difficult, but I can at least put some bounds on it. I can at least think about, okay, how often am I right or wrong about something like this when I have this much information for or against it just initially? Now, of course, this also means the smaller the probability of the alien hypothesis, that means there's basically more probability values that can then go to the others. So if the prior probability of aliens is really 1 in 1,000, then there's 999 out of 1,000 left for the other 3 hypotheses. So it would be the case that maybe the other 3 each one would be closer to, instead of a quarter chance of being right, instead of a 25% chance of being right, each one of those other hypotheses, if they're still equal, would all be about a third, or all about 33% probable. And all 3 of those aren't necessarily the best. For example, the extremely long ramp hypothesis, given the background knowledge we have of what would be needed to do that, that one makes it kind of implausible. If you need to have a gargantuan construction project just to do a gargantuan construction project, you almost are putting the cart before the horse. This might not even be possible. So we'd also think just initially that might be the lower probability in the end, and so on. Now, again, this is going to depend on having necessary background information. And ultimately, to have enough, you'd probably have to go into Egyptology. And even if you are there, you probably would then realize, oh, what more information you need to better figure things out. One of the things about becoming an expert is also realizing what you don't know and what might not be knowable. But that would be what you would need to do due diligence to even start figuring what those prior probabilities are, even if you don't assign an exact number to them. There's also more that could be said here. Now, I only gave 4 possibilities for how the pyramids were constructed. And it could be the case that all of them are false. It could be the case that how the pyramids were ultimately built by the Egyptians was done by a method or technique that we just haven't even thought up yet. Well, in that case, how do you possibly even assign the probability to a hypothesis you haven't even thought of? Or consider the case if you were living 200 years ago. Would you even conceive of the idea of special relativity? Almost certainly not, since nobody had done it then. And even up to the time of Einstein, the idea of it hadn't really come into fruition until the various bits of knowledge were coming together to make us go in that direction. So it could be in the case that in the future, for example, with the pyramids, maybe we come up with some new hypothesis that actually explains things better. So how do we account for that? Well, we do have one out, even if we can't actually assign a prior probability to a hypothesis we don't actually have. No matter what probability we think in the end of how the pyramids are built, what if we go through all the math, we do Bayes' theorem a bazillion times, and we find the probability, the posterior probability of how the pyramids were built? Let's say the ancient tech as we figure it hypothesis. Whatever that probability is, it's not going to be 100%. Which means that new information could come along and change our minds. It could be the case that we come up with some new evidence that doesn't fit the hypothesis but fits another one. Or it could be the case that we come along with some new theory and the evidence fits it better, even if all the evidence could fit our previous theory as well. Because this probability that we calculate in the end, no matter what, won't be 100%, it's always the case then that there's the possibility that it's wrong. Even if it's 99.99999%, that's still not 100%, which means it's still, at least mathematically possible, that something could come along and give us a new hypothesis to fit the data, or new data comes along to make a switch to a new hypothesis, or even potentially one of our older hypotheses that we had dismissed but now had found to actually be right. This happens in science all the time. So, for example, nobody had properly conceived of natural selection as the theory of evolution, the driving force of evolution, until basically the time of Darwin. So if you wanted to, of course, talk about the probability of Darwinian evolution to be true before Darwin, that would have been really hard to do. At the time, there was, of course, another theory of evolution, that of Lamarck. And even after Darwin, while many believed that he was correct that there was natural selection and they did accept evolution, they did not accept actually his methods of evolution. And there were several historical reasons for that. Part of it was about genetics, part of it was about ages of the Earth that were believed at that time that wouldn't have been long enough for the particular methods of natural selection to do it in enough time. They already knew the Earth was millions of years old, but Darwin required the Earth being billions of years old. So that was a problem. So it was the issue that ultimately there was background scientific problems with Darwin's theory of natural selection as it existed in the 19th century. But new information came along and fixed some of the problems. Our background knowledge changed. We did find out that the Earth was significantly older than had been previously calculated. And the problems of genetics were being resolved because of the discoveries or rediscoveries of the works of Gregor Mendel, for example. And various other things as well coming along to lead to a reformulation of biology and of evolution, and that basically said Lamarckian evolution was actually wrong. And of course, if you want to know more about Lamarck and Darwin, of course, you probably would be better assigned in a biology class. But our point here is simply this, that whatever you believe about your hypothesis now could be changed in the future because of changing background information, new evidence, or somebody even coming up with a new hypothesis you didn't even consider that can fit the data just as well. So if you are being a good Bayesian, even after you've done all the work and found what is your posterior probability, and even if it's absurdly high, you still have to consider the fact that something could come along to change your mind. This is a good thing. This means you are being rational, and this also means that you have enough sense of what your theory implies that you can tell if evidence fits it or doesn't fit it. It also means that you would be able to analyze new theories and see if the evidence fits it or doesn't fit it. Ultimately, if you can apply the techniques that are supposed to be a part of Bayesian reasoning, you can be a proper scientific thinker. This, of course, also means the possibility that also the extraordinary hypotheses might get proven right. Maybe the aliens did build the pyramids, but we would need, in that case, very good evidence, wouldn't we? For example, I gave the bound on the probability of aliens building the pyramids as less than 1 in 1,000. And the reason for that, I figured, is that, well, how often is it the case that a theory is right when it has so many issues against it? Issues of physics, issues of history, issues of there being better hypotheses to explain the same evidence, etc. It sure seems like having that much background information against it, it's much less often that I'm wrong about that 1 in 1,000 times. But because I don't know everything, it's possible that I find some piece of evidence that comes along that absolutely fits this alien hypothesis versus any other one. So, you may have heard the expression, extraordinary claims require extraordinary evidence. Something with a really low prior probability is what we would consider extraordinary. And in fact, 1 in 1,000, I consider to be generous, given the background information we know or have on hand about the alien hypothesis. I would think it'd be even less than 1 in 1,000,000, honestly. Because really think about it, how often is it the case that your hypothesis that goes against physics is wrong? And when I keep saying physics is wrong, the fact that the energy requirements to actually traverse space is so enormous with so much radiation by the ships, even under the most ideal of conditions, that it is just so absurdly destructive that aliens would actually have come in a timely manner from one solar system to another just to put a bunch of rocks in a pile. Let's just say this much. If I'm an alien, I'm traveling, and I'm using that background information of how an alien would think, my thought isn't to travel billions and billions of miles to pile up some rocks into a pyramid shape. In fact, really, the pyramids, while amazing, are really low tech. It doesn't even have reinforcing steel in it. It's less tech than the Colosseum, let alone the Empire State Building. If this is the best the aliens can do, they can go home. That's the sort of things that you think about when it comes to implausible hypotheses. But you do have to consider, okay, you do have to think what could be evidence that makes that plausible. What evidence absolutely fits the alien hypothesis and no other? That is the next step of Bayesian thinking.